All right, it's 8:30 and we are going to start on time. Yanping, go ahead.
Thank you, Maria. Do you hear me well, Maria? Can you confirm?
Yes,
Cool.
you are good to go.
Welcome to the 2023 DFW IT Talent Champion Competition final presentation. The past few weeks have been truly exceptional for our advisors, contestants, and volunteers, making this summer an unforgettable one. This morning, we are thrilled to have below 9 outstanding demos lined up. But before we dive in, let's take a moment to cover some logistical details. First of all, if you are contestants, please rename your Zoom name to be team name dash first name dash last name. And we will have a 10-minute break after demo 5. First and foremost, time is crucial. With 9 teams presenting this morning, precious time management is very important. Kindly pay close attention. Each team will be allotted a maximum of 10 minutes for their presentation, 5 minutes for Q&A. So in total, at most 15 minutes for each team. And our timekeeper, Julia and Jean, who has a timer prefix in their name, please make sure you find Julia and Jean. During your presentation, our timer will display a green card at 8 minutes, a yellow card at 9 minutes. At 9 minutes, I will remind you you have 1 minute left for your presentation. At 10 minutes, a red card will be displayed. At the 10 minutes mark, I will need to kindly interrupt to transition to the Q&A session. For the Q&A session, the time will continue. Our timer will raise green at 13 minutes, yellow at 14 minutes. Again, I will remind you have 1 minute left. At 15 minutes, when red card is displayed, a gentle interruption will follow to stop. Now, let's familiar ourselves with the judging criteria. Our prestigious panel of judges will evaluate each project based on below various factors. Please take a picture or make a note to get yourself be familiar with. Moving on, let's acknowledge our distinguished panel of judges who are Qiang Bai, entrepreneur and investor. Jingming Li, founder and CEO at Chova Technologies. Annie Liu, division CIO, Toyota Financial Services. Dr. Lucas Lu, founder, CEO, and investor at Byte Trade. Dr. Dong Qian, professor of mechanical engineer at UT Dallas, associate department head. Zhen Tao, founder and CEO, Tianda AI. Dr. Weili Wu, professor of CS at UT Dallas, lab director. Thank you, all the judges. Next, eventually, we're going to pick up a lot of awards. We have 4 overall awards from TiDB Grant Award, Finney Award, Laugh Loud Award, and 1 Honorable Mention Award. In particular, we want to award our contestant with single category award. They are Innovation Award, Design Thinking Award, Technical Achievement Award, and 3 Future Star Awards as well. Last, our event success won't have been possible without the generous support of our sponsors. A big thank you to PinCap, TiDB, Finney, Lock Lord, Cast Texas. Thank you so much. Now, I understand that the anticipation is running high. Without further ado, let the party begin. Please join me in welcoming the first demo from Team Surgical GPT, presenting their groundbreaking AI project. Leading the project team is Leslie Kuma Srinivasa, with guidance from project advisor Dr. Hong Liangren. Demo 2, Odyssey GPT, please stand by. Go ahead, Leslie Kuma.
Thank you for the introduction, Ms. Yingping. Welcome, organizers and the judges. Let me share my screen first. Okay, can I get a confirmation that you guys can see my slides?
I can see it.
Yes, we can see
Okay,
it.
thank you so much. Okay, welcome, judges and the organizers and fellow contestants. We are Team Surgical GPT. So our application, what we are presenting here is an interactive learning assistant for robotic surgery. My teammates are Gokul Kandan, Dr. Mubarakul Islam, and our advisors are Hong Liangren and Yingping has also been helping in the administrative side. So thank you so much for that. Okay, so let's go to the problem statement first. Our problem statement is mainly focused on surgical application in terms of training surgeons and surgical residents. Okay, so far in the training domain, in most cases, in addition to theoretical studies and hands-on practices, surgeons and surgical residents often watch pre-recorded surgical videos for post-surgical analysis and observational learning from observation. But although observational learning has helped them in improving their surgical skills, when they do have questions on very domain-specific surgical questions, they tend to they have no choice but to look up to surgical experts to answer their questions. However, the problem in this case is these are very domain-specific questions and only can be answered by those medical experts in that particular surgical subdomain. For example, if it's a gastronomy or it's a neurosurgery or whatnot. And there's a very problem in this case scenario is the surgical experts are actually very scarce and they are often preloaded with clinical and academic workload. So to keep asking them for doubts and or whatnot, to even ask them to make time to answer a question is very difficult. Here are some snippets of studies that show that actually even in the more developed countries such as US and Japan, they are actually facing a shortage of surgeons. So even if in developed countries, this is an issue, just imagine about developing nations as well. So if there is lack of expert surgeons and means you don't have a person to answer your questions on a timely manner. So in that case, even the country itself is not able to generate new surgeons because they themselves are finding it difficult to get answers for those expert domain-specific questions. So this is the problem statement we are presenting. And what is a possible solution? What if we are able to develop a reliable system that can mimic an expert surgeon in answering a domain-specific question? For example, the model is able to reason a given surgical scene and the question, and they are able to reason on both the vision and the language to actually generate a very language and vision reason surgical answer description. So this is what we are proposing a solution. So how is our design process inspired? So we think about how an expert surgeon do a thought process. So over the years, right, they have they have accumulated academic studies and hands-on practices and surgical skills, and they have actually a very big data base of their prior surgical knowledge, which is very big, and they don't. It's very vast. But when you give a very specific surgical scene and a question, right, basically they first understand the question and they actually reason the question with the surgical scene. And based on what they have, finds key cues or key words and whatnot, they actually go back to their prior knowledge and they understand which are the very narrow answers they must draw from their prior knowledge and they answer. So we take inspiration from this thought process of a surgical expert. Then we actually develop our application in the sense that we assume an LLM model specifically trained on surgical procedure as prior knowledge. And we also employ a multimodal reasoning model, essentially a VQA model that is able to reason the question and the surgical scene to prompt keywords to look into the LLM. So basically, we connect this multimodal reasoning prediction to LLM through prompt engineering to actually give a very condensed description that will actually help the surgeon to understand the surgical scene more for the question they have asked. So this is the application, and this is actually a very scalable element. So depending on which surgery you have the data set for, which surgery you want the model to train, you can specifically train the multimodal reasoning model just for the vision and language reasoning. In this way, you're able to actually address the lack of data set because you don't have to gain all the data set, all the possible data sets for all different surgeries to actually generalize the model. You can actually have a very specific multimodality reasoning model. And this LLM, right, can be trained based on very textual writing. So basically, you can just train on peer-reviewed papers and everything, peer-reviewed papers and manuscripts and everything. This is just purely trained on language, and this multi-model reasoning model is a very standalone model that is specific for this data set or this specific surgery in per se. So this way, this is multiple scalable. So you want a new surgery, you just add another multimodal VQA model for that specific surgery, and that's able to look up into the LLM for more description. So the solution we are presenting is a bit more scalable in that sense. So how do we design this? So the overall architecture is something like, given a surgical scene from a video and the question, the image and the question passes through multimodal VQA surgical VQA model, and it creates a very specific keyword answer. Together with specific keywords, the question and the attributes, for example, what is the type of the surgery, then we use a triple H, helpful, harmless, and honest prompting method to the large language model. And from this prompting, the large language model, for example, say ChatGPT, is able to create a very condensed description that is very much relevant to the very specific question. Just imagine changing this question to what is there surgery, any instrument present or not, or is there any safety issue with this surgical scene, then the description will significantly change depending on the answer predicted by the multimodality models. So this is the architecture. Our implementation is for a minimum viable product. What we actually did is something like we use a public data set, Cholek 80 data set, to create a VQA data set. So we call it Cholek 80 VQA data set, where you can ask about whether an instrument is present, what's the phase of the surgery and everything. And we created a ground truth for those things. And based on this, we created a surgical VQA model developed by our team as well. So this particular VQA model is also called surgical GPT, but don't have confused with the overall team name itself. So in this case, given a surgical question and the scene, we are able to predict the corresponding keyword answers. And we are using the prompting for triple H prompting. And the solution integration is to make it user-friendly for the surgeons, we actually created a gradual UI where the user will be able to upload the very specific surgical video, and they'll be able to scroll to different surgical scenes. And once they decided which scene they want to raise questions on, they can input their question, and they can just click the generate button here. So based on this, what happens is that the scenes in the back end, basically the scene is taken and the question is taken to the multimodal reasoning block. and the answer, keyword answer is predicted, and the keyword answer is displayed here. And it is also used for the LLM prompting together with the question, and the LLM description is also sent here for a keyword and also a very brief description about the keyword and the surgery around to give a holistic answer for the surgical residents. So let me go through a demo here. Okay, I think it's already open here. So in this case, right, you are able to actually upload a new video to this user UI, but since it's a data set for surgical application, we already preloaded a surgical video here. So you can just press the example video here, then you can just slide to maybe here. Okay, so let's say this is the surgical scene we want to question, right? We can just ask the question here, something like, what is the phase of the surgery? So basically the surgery here says preparation, and it actually gives a very brief description about the preparation phase of the surgery itself. Then you can also talk about instruments and whatnot. And for now, the data set is a bit limited, but it is scalable as long as we annotate the data set more. It is scalable because LLM is already trained on the very big surgical script. So it will already contains those answers in that sense. So in summary, okay, in conclusion, we propose and introduce an interactive learning assistant for robotic surgery that actually employs a multimodal reasoning and zero-shot prompting to LLM to create to generate responses that are very much grounded to the question and the provided surgical scene. The proposed system is very much scalable to new surgeries. You just need a data set for the new surgery in terms of for vision and language reasoning. Then after that, if you just train on a VQA model, standalone VQA model, that can be used to prompt LLM for those applications. When it comes to medical application, there's always a question about how reliable the answer is and how can I scale up. So for the future, there are very surgical domain specific challenges which we would like to address moving forward. First thing is people always think about incremental learning. How can I add new data set? How can I add new surgery? But we also want to focus on incremental forgetting.
Gentle reminder, you are at 9 minutes. You have 1 minute to go.
Okay. So basically, we wanted to detect, firstly, we want to detect and quantify LLM hallucination. Hallucination is where the LLM just generates random scripts or random answers, which might not be actually true in that sense. So we want to find a way to quantify and tell the user that the model has now hallucinated and don't rely on the answer just generated. Second one is incremental forgetting or unlearning. This is where, what if the surgical standard has been changed? So in that sense, we want to make sure that the LLM model itself can be incrementally made to forget a very specific procedure without forgetting other learned knowledge or without retraining the whole model again and again. So these are two important steps we are planning to work as our future work. So thank you. That's all from our team. And here are our academic papers related to this work. And you can scan the QR code to access our papers. And we are open for questions.
Thank you, Lalius Kumar. Let's open the question to all the judges.
Hello, can you hear me?
Yes, we can hear you.
Yes, I have a very quick question. A very nice presentation. So my question is, how do you quantify the benefit of your tool? Is there any way to quantify it?
How do I quantify? I believe the quantification comes to very specific answers. For example, yes, it is very easy to say what's the phase of the surgery, but what if the answer is able to go even in depth? Quantification wise, it will be a qualitative measure. It won't be a quantitative measure because the answer description itself will be relative to the person who's reading. And one way we could quantify is maybe we can open up to clinicians and ask them to rate how much info how much information, how much was the quality of the description that has been generated so far.
Okay, thank you.
Thank you.
Hello, can you hear me?
Yes.
Yes, ma'am.
Yes, yeah. So I have a similar question. Yeah. So first, it is a very nice presentation, very clear. Yeah. So how do you evaluate the accuracy? Yeah. So because for surgery, yeah. So that's very crucial. How do you evaluate the accuracy of your model?
See, thank you for the question. I think it is also related to the previous one, and I think I can, now I just remember a way we can actually evaluate. So basically, give me a minute, I cannot scroll to the previous slides. Okay, so if you remember correctly, basically we have two models. One is a multimodality model, which we train ourselves, VQA model, another one is LLM model. So what we can do is we have ground truths. It's like a classification. Our multimodality VQA model is a classification model. So in that sense, we would be able to quantify what's the accuracy of the model. For example, what's the accuracy, what's the precision, what's the recall. And we actually, the papers that I showed in the QR code, they actually report the results for these quantitative answers for keyword classification. So if we are able to quantify that this keyword is actually, the model has accuracy of predicting the keywords correctly, then to an extent, we can say that the whole description might be closely accurate to this percentage. If I believe this answers the questions.
Okay, another question. So from my understanding, so your model, yeah, so like the mainly based on the keyword to do, yeah, so that give the answer like that, right? Yeah. So however,
yes.
Yeah. So if in that case, yeah, so that is very, very basic for the LL model. Yeah. So if in that case, so because the keyword, yeah, sometimes there are lots of the misleading, right? Yeah. So do you think about to extend the keyword as the like the sentence like that?
It's a great question. We actually were going forward in that extent actually. So basically, in addition to keywords, right? What you see at the bottom are attributes, for example, surgical name and surgical type. And we're actually looking forward, we're actually working on multi-label classification. So if you just give a surgical scene, right, we will do a multi-label classification, for example, whether is this instrument present, what's the surgical phase and whatnot, right? Then in addition to this specific question answer, and we have a key question, we will also add the predictions from this multi-label models, right? Then it becomes, the description becomes even more narrower. So that will actually solve the problem of model hallucination based on just one keyword.
Thank
Okay,
you.
thanks.
We have 1 minute left. We can have one brief question.
I got a quick question. How many types of surgeries have you trained your model to solve for? And what are the sources of the information you used?
So far we have generated data set for 3 surgeries. Sorry, give me a minute. Yes, 3 surgeries, and the image, the surgical video is public data set, but the VQA questions is actually in-house. We annotated the VQA data set. With the help of clinician, we actually verify those answers, and some of the keywords are actually generated based on other annotations available publicly. So some of these are public data set, and we also have in-house annotations.
Thank you.
All right,
Thank you.
we're on time. Thank you so much, Surgical GPT.
Thank you.
Thank you.
Thank you.
Now let's welcome the demo 2, Odyssey GPT, who has brought their own project. The project lead is Nick Pan, and project advisor is Bo Gu. Let's welcome demo 2.
Thank you. Thank you, Tommy. Can you all hear me?
Yes, we can hear you very well.
Yes. Sorry about my voice. I partially lost my voice yesterday. Unfortunately, I got COVID, but if you can hear me, that's perfect. Thank you, organizers, and thank you all the judges for this opportunity. It's great to be here. I'm here to kick us off on behalf of Odyssey GPT team. Myself, Tommy, Sharon, Ray, and Shenru. So Tommy, if you can go to next slide. Yeah, so really the problem that we're trying to solve here is the very convoluted space of personal financing. So when it comes to personal financing, the problem is not that there are too few resources, but there's too much out there. It's very convoluted, it's very overwhelming, sometimes intimidating. And really, the solution that we're trying to build is to fill several gaps, which I'm going to go into. And as you can see, when it comes to personal financing, a lot of questions are being addressed towards mutual fund. If you ask myself, I'm not even though I work in financial service industry, I'm not an expert in that. If you ask me, hey, what's the difference between mutual fund and hedge fund? Chances are I'm not going to give you an accurate answer. If you go online, you search, there are all kinds of forums out there. There are all kinds of robo-advisors or ChatGPT-like products out there. If you ask those products, what exactly is your personal path to a financial freedom with a good combination of funds and other financial instruments, chances are you're not getting an accurate answer. And sometimes the specificity is also not there. If you ask something about yourself, if you enter some your personal variable baseline information, chances are you're not getting something that you're very satisfied with. And so the team did some research at the beginning. There is some solution, and there's a solution out there which is called BOGO Heads, presented by actually one of our team members, Sharon. So BOGO Head is a forum that a lot of investment professionals and users get on there. They talk about mutual funds, they talk about investment strategies, there are experts on there. But there's a problem with BOGO Heads. Tommy, if you go to the next slide. So really, I'm gonna throw out a buzzword out there. So like a very traditional Web 2 type of forum. One key problem there is navigation, right? You need to understand the structure of the forum. You need to look for the question that's relevant to you, and then you need to sift through different answers to really think about what's relevant and what's applicable to your personal situation. So navigation is one problem. On the other hand, ease of use, in other words, is the search cost, right? You may incur a lot of search costs when you get a satisfactory answer from a lot of information on the forum. On the other hand, there are other solutions out there, like GPT-like type of solution. Again, one example there is hallucination, right? You don't know if the answer you're getting is accurate, it's applicable, it's realistic. So a lot of questions. Again, the problem is search cost. You need to validate that answer from a different resource or from an expert. So really, this is the gap that we try to fill. And the team came up with a solution that we utilize a proprietary data source and then the architecture that the team built from scratch. So with that, I'm going to pass it on to Tommy talking about our own solution.
Yeah, thank you, Nick. So basically, just to address these problems that Nick brought up, we basically wanted an application in which we could utilize AI to automate the topic. But at the same time, it would be able to answer with that accurate info from BOGO Heads. And the advantages of that would be able to provide a streamlined space where we could just have a better place for the normal user, normal consumer to go and find the answer to their questions. So our solution to that is Odyssey GPT. Odyssey GPT is basically a ChatGPT-esque tool without the hallucination. Basically, we want to provide the right information gathered from those confirmed sources, such as BOGO Heads, but we also want to remove the unnecessary searching and comments that you need to go through to find the right answers to the right questions. And basically, we also want to give it in a format that is very concise and is understandable to the average user, instead of having to read through an expert's comments that may not have the terms that regular users will understand. And it just basically helps create a pleasant and simple consumer experience. So I'm going to pass it off to Sharon to talk about the architecture.
Hello, I'm not sure if everyone can see my face. I have some problem probably with my video. My name is Sharon. So I work with the team, came up with this architecture. the Odyssey GPT, we are using the most recent cutting edge technology for the front end and the agent and also the back end. So in the front end, we're using the Gradle. The agent, we are integrated with the GPT 3.5 turbo model with the LangChain to integrating the model with the vector data store. So I'm going to quickly walk through the whole process. If you look at the upper part, which is the data ingestion part, we're using the wget to scrape all those discussing the forums in the Boglehead to pull all the information into the HTML pages. And we are using the parser to transform the data into ingestible the JSON files. And those JSON files with all those discussion, the keywords and the detailed content, it's going to be converted to the embeddings and saved to the back data store using the model. So that's kind of the first step. And during the real time, during the runtime, we have a front end going to be demoed by Tommy later on, which is allow the user to ask anything specific to their financial needs. And then once the question being sent over, the GPT model going to translate the prompt inquiry into the embeddings, and that going to kind of compare with the knowledge base we store in the backend, which is embedding the back data store. Again, the LangChain is being utilized to pull things together. So that's the overall architecture. Now I'm going to pass over to Ray.
Yeah, hi. Thanks, Sharon. So actually for our data source, right? As Sharon said, we download all the some topic, 7,400 topics from Boglehead website. So roughly the raw data is 1 gigabyte, more than 1 gigabyte. And also we run program to pass this HTML file to some JSON data. That means we just remove all the unneeded HTML tag or something, just keep the title for the topic and also keep the content of the topic and replies. So our rough data for the model, for the training model is more than 220 megabyte. So yeah, this is our data source. So yeah, let me pass to Tommy for the demo.
Yeah, thank you, Ray. So as Sharon mentioned before, we do have a front end that is able to replicate this process. And I'm just going to put in a, can I just confirm that everybody can see this front end? Yes, okay. So I'm just going to put in a simple question, as we can see here, it is preparing the answer and grabbing the embeddings from the query utilizing LangChain. And as we can see here, we get a proper response. So I'm going to put in another question just to see the different kinds of response. And just as Sharon said, the advantages of this compared to ChatGPT is that we're grabbing from an actual knowledge base of those 7,400 topics that that Ray said that we were getting from. So
gentle reminder, Tommy, you have 1 minute to go for your demo.
yeah, thank you. Yes, so that is the end of the demo, and basically here's the appropriate response. So I will now pass it off to Shanru to basically talk about our accuracy.
Yeah, thank you, Tommy. Yeah, hello everyone, Shanru. So for this part, we use like 14 like independent test question and from like simple question and to the complicated, for example, like long-term financial plan. This question one is kind of from for example from Nick. He's very experienced on his financial questions, and also for me, I'm general idea about like finance. So usually for this question, you can say GPT can answer. Like the accuracy is about like 65, and it's very good at answering some simple financial questions, especially with this GPT. The database is basically the Boglehead, but it's later kind of not good so far to address some complicated finance questions. For example,
sorry to interrupt. Given the time, can you wrap up your presentation in 10 seconds? You will have time to show the remaining slides during the Q&A session. Thank you.
Okay.
10
So
seconds.
that's kind of general for this. So the next slide, Tommy. So this one we think the GPT can be very accessible financial advisor, and also can revolutionize and modernize current financial standards, and the potential, like think customers, and even it's about like anyone who has a donor, no matter regardless of the knowledge of the finance. And also so far we think based on some of the data we have extracted, I think the accuracy is 19%, and the future implementation will be use even more data for better results. Also, we can train some like model to have, especially for some knowledge which cannot extract from burger head. So that's I will pass to Nick. Thank you.
Thank you. Given the time, we will open to the Q&A session. I think the entire team will have opportunity to show the more details. Judges, please raise hands, and if you have any question, or open your mic.
Hi, this is Annie. I have a question. I'll let you speak to what you couldn't finish in terms of challenges. For the scenarios where this is not as accurate, what do you think we could do to improve the accuracy?
Can I take this question, team?
Yeah, go ahead.
Okay, since this is our first try, and it's surprisingly good because we only ingest 10% of the discussion board out of the Vocalhead. This whole product could be enhanced, and we could further tune in and continue to enhance the knowledge base, because now the Solar knowledge base is based on the Vocalhead. In the future, we could look at any public site, for instance, the Vanguard, Fidelity, which is two giant advisor firms, and also Bloomberg. They have a lot of information available, and we can continuously keep kind of enhancing the knowledge base to make the system and provide more accurate answers.
Wonderful. And so you feel that this will help solve those more complicated scenarios where further analysis is needed and the answers aren't as straightforward?
Absolutely, absolutely. Yeah, this is just the beginning part. Eventually our goal is trying to provide this tool to the hands of everyone. They could not afford any personal advisor or robo-advisor, which is very expensive. And the Vocalhead, they have a lot of people volunteer to offer the answer based on specific scenario, based on any particular person's situation, financial situation. That's the ultimate goal. We try to make personal advisor or financial advisor available to anyone.
Thank you, Sharon. Thank you, team.
Any more questions from our judges?
There might be a problem with your demo site. I just went to a demo site, it loaded okay, but I asked a couple questions and it's taking long and not giving an answer. So just FYI, it could be a problem with the demo site.
Thank you. That might be well related to the EC2 instance we standard under AWS site. So maybe Ray could take a further look. Second problem probably could be the API key, the embeddings. Yeah, I'm using my personal embeddings, personal account with the embeddings. That could be another problem. They have some limitation, the count, how much money I can use. But thanks for the information. Yeah, we're going to take a further look.
We can take one more question if judges have more questions. All right, I take that as no. Thank you so much for Odyssey GPT team. Thank you so much. Next, let's welcome Demo 3. Demo 3 is it's a Slough team. They're going to present the Intelligent Travel Assistant project. The project lead is Helen Lei, with guidance from project advisor Kevin Xu. Helen, please share or present your screen. Is Lars team here?
Yes, we are. We're just working on sharing our screen right now.
All
Sorry,
right.
Sorry, we're having issues sharing our screen. Give us 1 second.
Okay.
Wait, is it possible? I know I was made co-host. Is it also possible the member that was supposed to share is Cindy Liang? Could we also give her sharing permission?
Yes, sure.
Thank you so much.
Yeah, can our Zoom host please give presentation permission to Cindy Liang?
Sorry, it's not a Zoom permission. I need to, it's like a system permission. I'm sorry. We'll figure this out in a second.
Can everyone see my screen?
It's loading. Yeah, we can see your screen.
Okay, great.
Okay, so this is our intelligent travel agent app, and we wanted to use artificial intelligence to plan the perfect travel itinerary. Go to the next slide. So as we all know, planning travel is a very stressful event, and the problem is that current travel itinerary tools are rather convoluted and not simple to use. And trying to plan travel by yourself without any tools is also just really hard, trying to figure out hotels and flights, where to go. And it's definitely a lot of work and a really hard process, which is why with our app, through using GPT software, we hope to ease the process of generating itineraries through chats with our AI agent and initial prompt engineering. Further, we provide options for users to chat with the agent if they're unsure where to travel at, all through a simple, easy to navigate user interface. So in order to address this problem, here's our product strategy and vision. Our target audience is young travelers who want safe and exciting travel. Since the AI travel agent is an app that can suggest fun and safe travel itineraries and new locations, and especially for young people who are trying to plan travel for the first time, like a lot of people planning senior trips and stuff, we know that it's hard, so that's why we wanted to target them. And what makes us different, unlike ChatGPT, our product is more user-friendly and tailored directly through building travel suggestions and itineraries. So this way we streamline the process of using ChatGPT. And the bottom line, we hope our app is a one-stop location for users where they can generate travel suggestions if unsure, build an itinerary, and receive hotel and flight suggestions.
Okay, so our solution that Helen outlined to the problem that Helen outlined to you is to create this simple to use app. So the users would open the app to this home screen that gives you 2 options, either speak to the travel agent or view the itinerary history. If they wanted to speak to the travel agent, they could click the button and it would take you to the second screen, which would allow the users to input a few pieces of information, including where do they want to go, what the purpose is, when they want to go, and for how long they want to go. And also, if they don't know where they want to go or the location they want to go, they're able to click the chat with our agent button to kind of also speak to the chat, to speak to the AI chat bot to help them figure out where their final destination will be. Then once this information has been inputted, they'll be able to just click next, and the travel agent or the AI will give them an itinerary, and they'll be able to directly talk to or edit the itinerary with the chatbot. And then finally, once they click done, it'll give them a finalized itinerary that they can save and access at any time. So how our application works from the front end to back end. So the AI chatbot is adapted from the Swift LangChain package. And as I said earlier, the chatbot will take in the user's input location, reasons for travel, length, and date. And Finally, the chatbot will use this information to generate an initial itinerary. The user will then be able to, again, interact with the bot to edit the itinerary and then click finish to see the final itinerary. And by clicking the done button to see the final itinerary, the bot's also going to be able to prompt the LangChain agent to generate flight and hotel suggestions. So not only do they have events planned for what they can do on the trip, but also how they can fly there and which hotels they can stay at. And additionally, on the page for the user inputs, there's also an option to chat with the agent to decide where to go if the user is unsure.
Going back to the homepage, there were two options. You can either choose to build a new itinerary or view past itineraries. This page shows all the past itineraries that the user has previously built using our chatbot. The user can click on any of these buttons and it'll take them to their final itinerary page where they can always refer back to when they want to see their past itineraries. So here we have a video of our demo. So here, you're asking the travel agent for a recommendation on where to travel. This is assuming you're not entirely sure where you want to go yet. So here I said bagels in city and it recommended New York City. And then here you would be inputting the desired travel destination, the purpose, where when you want to travel and how long you want to travel for. And then these are parameters that we'll give the bot. And then here the travel bot will output an initial itinerary. And then this is the final itinerary. And right now, the app is calling our backend to receive the flight and hotel information. It will take a while because it has to communicate with the Google Cloud and the API. But here you can see that it has the final hotel and flight suggestions for the user. And then going back to the homepage, when you see past itineraries, this also pops up and populates on that page. And then here, I'm just building another one so you can see a list of past itineraries. Jennifer, you can skip like towards the end of this video. Yeah, you can, this is, yeah. And then you can see like, there's like that new itineraries also shows up on the past itineraries page. And then going to the second video, I'll show you how you can edit your itinerary. So here I just pre-populated some information and then I sent it to the chat page. And then the travel agent will output an itinerary. And then I'm going to ask the bot to add breakfast because they haven't added that to the itinerary. And then Jennifer, you can skip like 2/3 into the video. Sorry. Yeah. If you, now this itinerary has breakfast options added, so you can easily edit the itinerary through the chat function as well.
So this is a little bit more about our product journey. So to summarize our process, we started with some initial planning with research of like current ChatGPT tools or itinerary planning tools in the market right now. And then we worked on some of the user interface design to make sure that everything is very, looks like it's accessible and it's very intuitive for the user. And then we also worked on the front end and back end development, starting to work on that with each other. And then also implementing the OpenAI models with further development in the upcoming weeks, and then finishing touches. So in conclusion, our product began with preliminary user interface design, and then a division of the front end and back end development. And some of our biggest challenges was implementing the OpenAI models because there aren't many packages that exist on Swift, but we were able to tackle this challenge by coding the AI component on a Flask app that was deployed and accessed through HTTP requests in our app. And we were able to creatively solve our initial problem statement by providing a friendly travel agent for users to chat with to receive itineraries and also gain hotel and flight insight. Currently, the AI is not 100% stable and accurate, but our future hopes are to develop a model with an AI with greater accuracy and consistency.
Thank you, Sloth team. Let's open the floor to judges to ask any question they have.
Yeah, I have some questions. Maybe I don't understand fully. So your app is based on OpenAI's GPT model, right?
Correct.
Hello?
Yes.
Okay, and you don't have your own data. You are relying on GPT to do whatever necessary to get whatever the data GPT is based on. You don't really have your own special trained or patterned data. Is that right?
That's right.
Then I don't really see how you can make a difference between what you are doing with, for example, if I get someone else to do it, because it seems to me it's, the logic is quite simple, just to do some, specific queries towards GPT by feeding in some, standards. From your demo, I feel you really need to consider the budget, the mood, the weather, and a lot of other things. But all these things someone else can also do. What is your difference here?
Yeah, that's a really good question. So yes, I think the GPT model from OpenAI was really smart, so that there wasn't much tuning that we had to do to implement it into our front end. However, on the very last page, there is a flight and hotel recommendation. And for that one, we built our own customized link chain agent. That was not built in Swift because there are no pre-built Swift packages to supplement that. So we built that in Python and deployed that as a Flask app. And that's not just something you can use ChatGPT for. So that's kind of what we did differently. Also, just the overall integration of building this front end and integrating all these different tools is not just something you can just search on ChatGPT, which is kind of how our idea and our product is different and not just something someone can do in an hour.
Sure, thanks.
Any more questions from judges?
Hi, team. This is Annie. I like that you have a very targeted audience for your tool. I'm wondering, what are your thoughts on how do we improve this tool to become more personalized and customizable for your young traveler?
I think the previous judge, Chung, did bring up a good point about how we didn't train it on our own data. I think maybe adding more, there is already a built-in memory component with the chat, but maybe building in further app persistence, having the app remember previous data that the user inputted, and then running the models based on previous chat history or current chat history, but also previous chat history, so that the model is able to remember kind of what the user prefers. So whenever they build new itineraries for new locations and new dates, they kind of remember what the user prefers.
Got it. And then so if I'm understanding the tool correctly, on the back end, you're really trying to pull together distributed information to present to the front end in terms of travel itineraries. Is that part of the target of what this tool is aiming to achieve?
Yes.
Thank you. Thank you, team.
We have 1 more minute left. One more quick question if judges have.
Okay, I will take this chance. Yeah. So yeah. So first, this is very interesting, and I believe so if it will get the well developed, so maybe so it's also has some impact. Yeah. So can you justify why you are targeting at the beginning of the project goal? You are targeting to the young traveler, not general traveler. Yeah. I think that's a simple question. Yeah. So your project, you're targeting the goal, you're targeting for the young traveler. Can you hear me?
Yeah, we can hear you.
Yeah. So why?
I think like apps are very easy for young people to use, and young people don't have as much experience with traveling as older people. It's like very common for young people to have this desire to travel, but they might not have as much experience as someone who is older, and they need this type of guidance when it comes to where to travel, how to travel. So and apps are also very easy, and young people are very familiar with using apps, which is why we want to target the young audience with our product.
Okay. Thank you. Yeah.
Thank you, judges. Thank you, Team Slots. We are right on time. Now let's join me to welcome Demo 4 from Team Algo Navigators, presenting their project, Intelligent Travel Assistant. Leading the project team is Alvin Lee, with guidance from project advisor Kevin Xu. Demo 5, Travelist, please stand by. Alvin, please share your screen.
Hello, can you hear us?
Yes, we can hear you very well.
Okay, that is good. All right. Oh, all of us are in the same call. We are all together.
We're all together in the same room.
Yeah. So
Alvin, I will propose whoever is speaking, please speak a little bit to the mic because your voice is a little bit low.
okay. So, okay, we're ready. Hello, we are Group 4, aka Algo Navigators, and we created a travel agent / planner. I am Vishnu Nambiar, and I'm representing our team alongside Shramoy, Elvin, Akshat, and William. We also received mentorship from Kelvin and Julia.
So the problem with today's travel planning sites is that they are slow, confusing, and often overwhelming for users. They're usually specific to one part of a trip, such as flights, hotels, rental cars, etc. They require you to know multiple details for your trip in advance. There's no suggestions for other parts of your plans beyond what you're looking for, such as flights. They lack in creativity when regarding your personal interests, and they don't solve the issue of coming up with the perfect vacation that really is fun and doesn't remove the stress from the plan.
The impact of Algo Navigator on planning is our innovative design and travel assistant is designed to transform the experience. Through intuitive conversations and AI-driven recommendations, it simplifies the booking journey, replacing convoluted interfaces with natural language interactions.
Algo Navigator team, sorry to interrupt. Can you try to intentionally speak a little bit louder? Because
yeah, we can try raising the volume and everything.
Yes, please. Thank you so much.
Is it better now?
Very good.
Okay.
Do you want us to restart or should we just keep going?
This is good.
Okay.
Yeah, keep doing. Yeah.
Okay. Traveling before the Algo Navigator led to more risks of manual errors when keeping records and creating documents, limited channels of communication, and longer and more time-consuming processes and projects. But using Algo Navigator, we were able to increase accuracy when it comes to crunching numbers and record keeping, more ways to effectively communicate and collaborate, and real-time data found rapidly personalized just for you.
Our product strategy and vision. So Algo Navigator aims to put the joy back into travel. So a few of our goals, inspirations, and objectives here. First, we wanted to create an interface that is easy for users of any technological background to use. collect basic information and create exceptional travel experiences with minimum inputs from users. And it's inspired by friendly human travel advisors and the intuitive and easy to navigate interfaces of existing chatbots such as ChatGPT. It has a dynamic but purpose-focused chatbot that helps plan a remarkable trip while not overwhelming users or getting sidetracked like a normal GPT-powered chatbot. And finally, it's a fully functional, real hotel flight and contains pricing data where there is no fake travel information.
So for our product, the core technologies are as follows. Python was our main back-end development tool. And we also use LangChain to fully harness the capabilities of the ChatGPT API. We use HTML and CSS for the front-end development, along with Bootstrap and JavaScript for styling. We use Flask as our web framework, and we use Selenium and Beautiful Soup to
as a web scraper
to scrape all of the flights and hotels and other data. SQLite and SQLite Alchemy allowed us to access the database, use for login systems and store any other information we need to. And we use Git for version control so we can effectively collaborate with our other users.
So Algo Navigator's intricacies. So for LangChain, we use LangChain to process GPT through provide responses to adapt to the user requests that we have. We have prompt engineering to make Algo Navigator behave like a true travel assistant and guide users to plan trips properly without being sidetracked. We use Flask as a lightweight web framework to translate information from the chatbot into an aesthetically pleasing application with a seamless user interface. We have a web scraper, which provides us with an easy-to-use WebDriver that interacts with websites in order to obtain real-time data that using information from the chatbot. And we have a SQLite database that allows us to store user-specific information such as trip itineraries, critical user login information, and encrypted passwords.
Unlike a regular ChatGPT, we obtain real-time details. Using Selenium and Beautiful Soup, we provide current flight and hotel options, and we also obtain activity and restaurant recommendations. So in conclusion, the journey to develop Algo Navigator was not simple. LangChain's platform was useful, had useful features, but also was challenging and occasionally unwieldy to use. Creating a suitable parser was a debated hurdle for the team, and web scraping was exceptionally demanding due to parsing, transferring, and interpreting complex JSON file data. Priority was given to acquiring precise hotel, flight, and travel details for clients, and authenticity was prioritized over simpler alternative. Instead, we chose to create an innovative solution that provides users with real-time data and deliver a feature-complete product. Once again, we'd like to thank Kelvin and Julia, and we hope you enjoyed the demo.
Hello, my name is Elvin. I'm here to provide the demonstration for our app, the Algo Navigator. So as you first log into our app, you're directed to our homepage with some login credentials on top right. So first, let's make a sign up or a test profile. I'll just call it test. My name is Elvin. And we'll just create a sample password. So first, as soon as you log in, you're able to access the multiple components of Algo Navigator. And in order to plan travel, you have to go to our chat section. So let's go there. And let's say I want to go to Barcelona. So first, let's just say I want to go to Barcelona, Spain. And I am from Dallas, Texas. So nice. It has information that we want to go to Spain from Texas. And now it wants to tell it what activities to do, types of food to eat, and also the dates we want to travel. So first, let's break it down. For activities, I've never been to Barcelona. So let's say I want to ask Algo Navigator on what to do, and I will simply do that. I don't know what activities are in Barcelona. Can you give me some suggestions? So when this happens, there are multiple suggestions that it gives us, such as these places that I'm not going to try to pronounce. However, let's assume that I like all of them for time's sake. And let's just say I like all of those activities. Please add them to my plan. Nice, it's added all the activities to our plan. And now it wants to know what days to travel. And also the flight class that I want to go in. So let's say I want to go on September 1st and come back September 10th. And I would like an economy flight. So nice. And let's say I want to edit, and there's one thing I need to still add, which is the restaurants. It said it earlier, but I just want to specify. So let's say I want to try traditional Spanish cuisine. Could you suggest some restaurants? And nice, it's giving us some restaurants that are within Barcelona that kind of fit within the criteria of traditional Spanish cuisine. So I will tell it to add it to my planner. Let's say specifically these two restaurants. So at this point, I believe our travel plan is done. And what you would do next is click this Finder button, in which it will generate our flight.
Gentle reminder, Alvin, you have 1 minute to wrap up your presentation.
All right, sounds good. So what's happening currently right now in the background is our web scraper, along with the different Python scripts, are searching for different flights and hotels across the internet, specifically through Google Flights and other hotel websites, and basically storing them within our database. Once it's finished, it'll prompt us to a different page, which is this one, Plan Your Dream Trip. We're able to view the trip options, such as the different flights. We can expand them to see the details. And let's say, for time's sake, I just want to select the first one of each. So flight 1 and hotel 1. There's some information such as the price, rating, location, the departure time and whatnot. And down here, there's activities in which we can edit if we wish to. However, I'll just submit. And here we see different flights that's found for us, such as departure flight, returning flight, as well as an itinerary containing the hotel, activities we'll do in different restaurants. Now these buttons, they fetch real-time data. So none of this is artificially generated. All of it is real. And if I were to click it.
To interrupt, Alvin, maybe can you wrap up your presentation in a few sentences?
Yeah, sure. So in general, our Algo Navigator is able to find real-time data and scrape it from the internet and based on the user queries. And yeah, thank you for listening to the demonstration.
Thank you so much, Algo Navigator's team. Let's open the floor to judges to ask questions. Judges, do you guys have any question?
I have a simple question. So this is very nice. My questions, when I am traveling following this plan, will this tool be capable of providing certain reminders, when I'm in the middle of the travel, or guidance, for instance, if I want to visit a place, would it be able to provide, for instance, a map or, some kind of itinerary?
You are able to ask it to generate an itinerary. However, a live map is not exactly provided. But if there's any edits that you want to make, you could add it at the end where the submit form was available.
So a lot of the actions taking place before the travel, right?
Yes, majority of the action or majority of the interaction is just natural language based between the user and the chatbot.
Okay, thank you.
We still have
team. Yeah, hi team, this is Annie. I'm wondering, are there any features that you wanted to have as part of this product that you didn't get to?
We wanted we wanted to be able to create a mobile application as well alongside this website. So that was probably one of the things that we would want to do in the future.
Got it. Thank you, team.
Do we have more questions from our judges? Go ahead.
Hello. Yeah. So another simple questions. Yeah. So to my understanding, so your app is for the all connected to the like the real time. For example, like the flight price, like the entertainment, like the right. Yeah. So like the activities. So in such case, so if the like, so for example, right now today I got your itineraries, yeah, for some, for example, 3,000 for the whole package, but maybe the real time tomorrow the price will be changed, right?
Yes, of course. The data that is recorded is definitely from the moment you actually click that button. So it is going to be outdated if you want to look back at it at a much later time. But yes, the links would still be updated, however. So if you clicked on the links, it would still refer to the flight, but maybe the numbers would slightly change. It would refer back to the same exact flight. If that's what you're considering with, and the hotel too.
Because yeah, another question is, yeah, so if the like the traveler has some constraints for the travel budget, can you also, yeah, so like the AI, the tool, can you also generate like the candidate the itineraries?
Yeah.
So right now, we don't have all the features for budget customization, but one of the key features we have right now is choosing the flight class.
Activities like the locations like that, right?
Yeah. So the good thing about this app is it's very dynamic. You don't have to always go through the flights. You don't always have to book hotels. You can also just interact with the chatbot and search for low budget activities, premium activities. And if you did you want to find a flight, you can choose economy class if you don't want to do business or first. But one of the main point of interaction is the chat box, and you can, it's very dynamic. You can choose whatever activity you want that fits your budget.
So is that very easy to extend, like add some later to add some like the more features for your current like the architecture, the model? Is that easy to extend?
It is not necessarily easy. It will add, this would be more of a question, well, a implementation through Selenium and the actual web scraper aspect, because adding like specific budget markings, like I want flights below $1,000 or below 500 specifically, it's much more difficult because the sites we use currently may not have the inputs for that directly. It may require another site or another area along the inside of the internet to actually find this information. So it would require some more research, but it would be definitely doable.
Okay. Okay. Thank you.
I guess we have 30 seconds. Our Judge Chiang can briefly ask the last question.
Yeah, I just don't really see the value of this project, to be very frank. I really think this is not much different from using Google. You know, in China, there is a website for many years, I think at least 15 years. The name is 去哪儿. It can, if you type your, Beijing to San Francisco date, it can list all the possible flights for you. Then you pick the right flight for yourself. So, you know, what you have shown me, not much difference from the 15-year-old 去哪儿 or anything I can do with Google. I don't need such an assistant. If I need an assistant, like today, I will tell my assistant, I will go to Singapore for the Singapore 2049 Web3 conference, November 11 to 15th. The rest, he is going to figure out for me. Now, what are you showing me is just a little bit complicated Google. So I just don't see the value.
Thank you, Judge Chiang. Given the time, Algo Navigators team, can you address Judge Chiang's question in the chat? We have to move on to the next demo. Thank you so much. Our next demo is Demo 5 from Travelized team, presenting their project Intelligent Travel Assistant project. Team lead is Mei Lin, is Pinola, and then project advisor is Kevin Xu. After this presentation, we will have a 10 minutes break, and I will have my timer presented on the screen. Meanwhile, Demo 6 Unity team, please stand by. May, please share your screen.
Got it. Okay. Okay, hello. I am May from Team 5. I'm the only member of this project. My advisors are Kelvin and Julia. So mine, I'm going to be pretty straightforward. Mine is a bit different from the other ones that you have seen. Mine, I researched a lot of features from the already existing ones. So you'll see about that later. So there's an addition in my project. So let's talk about the issue right now. So it is the age where dream vacations are marred by crowded attractions, long queues, and a disconnect from authentic experiences. So the travel industry faces a critical issue. Mine is based on over-tourism. So popular destinations are straining under the weight of mass tourism, leading to environmental degradation, overburdened local resources, and an erosion of cultural integrity. So in this scenario, travelers are left yearning for stress-free, personalized trips that celebrate local cultures and empowered communities. So we need a solution that reduces the impact of over-tourism while enhancing the quality of travel experiences that has never been more urgent. So just to give a brief summary. So over-tourism, we have some main problems with people going to places and they're not satisfied with it. They want to go to more places, but they don't know their preferences that well, or they only pick the most popular ones. So that adds on to more over-tourism, right? So they don't know where to look. And if you go on ChatGPT, if you go on any popular website and you ask them, hey, I like, what are some popular tourist destinations for blank? They're going to give you the top ones, right? So that's not really unique. That's not really giving you any room for preferences, for more customization. So there's some improvements on that. So my main functions is to simplify. We want to simplify the whole traveling process for users, especially in the planning process only, because I'm not competing with, let's say, hotel tickets, flights. They've already have their own state-of-the-art top technology, right? I'm not doing that. I'm trying to simplify by giving the users a personal, like a mini plan. So first you can generate snapshots of places you want to go to, and you have a short description that is based on your interests. And then once you click on that, you can get to Google Maps and location information. And then finally, the most important part is the drag and drop feature. So you'll have a planner right beside you, and you can drag and drop customized little snapshots that you like. So first of all, we have our smart tagging, like I said. So let's switch to the actual web page. So in our smart tagging, we have some pre-built-in tags for you, but these are the only pre-built-in tags. So what you do is you type, let's say I like China, or I'm interested in Chinese culture, and it extracts the word China from there. And from then on, anything other that you type, it moves on with your current search query. But for like history purposes, if you want to keep searching something, you can put the tags on it, and then it'll keep on going through that. So once we have that, it'll give you a few of snapshots with a description. And the most important thing is the drag and drop feature into here. So you can drag and drop and plan out your day with, let's say, some notes or some times. For example, I start my day at 6. I'm after lunch, I'm here at 1 p.m. I go here. And then what you'll notice is that once I drag onto here, or it doesn't have to be dragged on. You can just click on it from anywhere the itinerary is generated, you'll go here. So what I'm saying about no redundancy is that you can already see the reviews from here. You can already see directions and all that. Google does that. I don't need to do that again. So I'm just going to give you the link to it. And it may look better if I incorporate it better. That's a future expansion, but that's not the main features that I'm focusing on. So the calendar is probably the one thing that I analyzed.
like if you go on best 7 examples of travelers, you see hotels, you see flight, planes, tickets, all of that. They have their own custom LLM. I'm just using Google's API with my added on preference tracking and all that. That is the purpose, not trying to look for things that people have already done. Okay. So you can do that. So you can have smart tags as one. Another thing is location tags or types. So these are major categories of attractions, cities, countries, transportation, accommodation. So what you'll notice is there are different levels. There are countries, which is broad, and attractions, which is very specific, right? If you go on ChatGPT and you type, I like China, I want to see historical things, there are not that many room for, there's not that much room for customization and or promotion or ads. Even if you want to add that, there's not that much room, right? You're going straight up, ChatGPT is going to give you specific places. But from here, if you click on countries or cultural, you can search for broad things that fit your needs. That way you can search in more detail later on. That allows for more promotion room, ad space, and more chance for you to discover what your preferences are and what you really want, where you really want to go. So that also reduces over tourism. Okay. So are there any questions? While I find my, okay. So I mainly used Google API custom search and ChatGPT's OpenAI.
May, are you done with your presentation?
Yes.
Okay, cool. Now let's open the floor to judges to ask any question.
Hello?
Yes,
Hello.
we can hear you.
Oh, yeah. Okay. Yeah, so this is a very interesting interface for the travel, like the smart AI agent. So my question is, yeah, so the like I like your like the interface, yeah, so which incorporate the like the lots of the like customized the features.
I'm heavy on that.
I think that's, yeah, so that's very impressive. Yeah. My question is, what's the main challenge, technical challenge, yeah, when you develop this project?
That's got to be figuring out the different, it's extracting, number one, the preferences from user input, because that's pretty difficult to determine because users are complicated. They like this one, they click on that one. So I can do keywords. I do selections, I track all of that and then give them these smart tags right here. Another challenge I think is looking at what to specifically put as my, you know, the Google links right here. So it was hard deciding which one to use because some of them, if you click, if you just search up, if you search up a specific place, they give you that place. But if I search up the Peking duck, so there's a reason why I use this. If I search up like a category or a food, it also gives you the restaurants, right? So if I figure out and help the users that they also may like a food, if I click on that link, it'll take them here. So it'll find accurate restaurants for them instead of using ChatGPT straight up to search outdated restaurants or not inaccurate ones. So that would be, I think, a difficulty was figuring out which one to use for this.
Then, yeah, so following the related question is, in your project, what kind of the like the technique you decided to get the best the solutions for this to tackle this the challenge you just mentioned?
Yes, so the challenge I just mentioned, either I had to go online, search for specific restaurants, or I had to use ChatGPT for accurate information and location information, which is not very good. So that's why I decided to use Google's custom search API with the different places and categories, so it's all in one. And in the future, I would like to, so you see these categories, right? I would like to have more customized links. So maybe food places, I can use a different food API. It'll have a different link when I click on it. So that's something I would like to expand on. It was also why this was implemented like this, instead of just straight up doing it. I separated these for a reason, but you know, I am a one-person team. It was kind of difficult to do that, but I think I prioritized it.
Thank you. Yeah.
We can take one more question. Do we
I
have?
think you really put a lot of thoughts into your product, which is very good. It's at least it's not just a straightforward plain text chatting. But
Yeah,
I really think you are, you are putting too much emphasis on using Google API. So this is really similar to me, like advanced search. So it's not, you're not really using the GPT's power. Again, I think the past 3 projects, all of them are focusing on traveling. If I were you, I would come up with a scenario, a use case. Let's say someone living in Dallas, Texas, a redneck, has never been to Japan, and he wants to take his family to Japan. Give me a 10-day schedule, starting from day 1, arriving in Tokyo, where I should go, where, which hotel, and then which restaurant, blah, blah, blah. That's more valuable. So that, because at least by having that, I don't need to go to a travel agent. But now what the past 3 projects are showing me, I still can have to go to a travel agent, or I can go to Google. I don't need all of you. That's my opinion. Thank you.
Thank you. I would like to add one little thing. What you said, I saw, it's called Roam Around IO online, and that was a huge inspiration for mine as well. So I decided, instead of just giving you a 10-day plan, it was flexible and you could choose what you would put instead of a blurb of information. Thank you.
Thank you, May. Thank you, all the judges. This wrap up our first 5 demos, and we have 4 to go. And meanwhile, let's have a quick break. I'm going to set a timer on my screen. Let's come back at 10:05 in Central Time. Hey, unit team, Ryan, are you here?
Yeah.
Yeah, can you share your screen? Because I like to start our presentation on time.
Yeah, sure.
Yeah, I'll introduce your team once you share your screen.
Should I introduce my team now?
Yeah, I'm going to introduce you. Hi, everyone. Welcome back. Let's continue our second part of our presentation today. Our next presenter is from Unity team, and they are the last team who is presenting the project Intelligent Travel Assistant. Team lead is Ryan Zheng. Advisor is Kevin Xu. Go ahead, Ryan.
Thank you. Good morning, everyone. As she mentioned, I'm part of Team 6 Unity. I'm the team lead and the lead designer. Our product is TravelFlux, a travel assistant that helps you wherever you are, whenever you need it. Before I begin, I want to give some special thanks to our advisors, Kelvin and Julia. They helped a lot during the process and they gave a lot of good assistance, and we're always readily available whenever I need help. And also thanks to every judge in attendance for taking the time to be able to listen to this presentation this morning. A quick introduction of my team. These are my team members. I'm the only one presenting today, but these are the other people that are part of the team. So what is TravelFlux? So TravelFlux is a chatbot designed to serve wherever, whenever, for any travel assistance you need. The purpose of TravelFlux is to be able to help you with anything related to your travel plans, whether it be booking, planning, even any help during your actual travel itself. Say you want things to be translated, things like that. The main goal is to be able to have one central product that can help you from start to finish. So before I get into the product itself, we need to understand kind of the problems that arise in modern day travel and travel agents that exist today. The first, that travel agents in the conventional sense require another human, which this is a big limitation because they have their own schedule, their own time constraints. They also have a lot of different customers that they're trying to get a hold of, which makes it getting help on your own schedule kind of tough. Another thing is there are so many different places that you can get information nowadays. There are a lot of different companies, different places that you can do different things, and then a lot of them have a bunch of different ways that they present this information, doing a lot of this by yourself a big hassle and takes a lot of time. And the last problem is the fact that there is so many different details that a lot of these hotels, restaurants, attractions, etc. have that makes it hard to keep track of them all. There are so many things that each thing has that are unique to them that sometimes it makes it hard for you to remember everything that something might have. And that makes it tough to make travel plans because you obviously want to create an itinerary that suits what your preferences are, and then something that also keeping track of all those things from time to time can be tough if you have a lot of constraints and different things that you want. So then these three things can boil down to three things: unavailability, inconvenience, and information overload. So then how do we address these problems? Well, our product is made so that it can be available anywhere at any given time. No matter where you are, it will be able to help you with any kind of problem that you may run into. Our product also does all the searching for you. You don't need to go by yourself and search up everything that you need to know. Our product, given you tell it the preferences that you want and the information that it needs, it will help you search for everything for you and give you options so that you don't have to take the time to do it yourself. And then it will also keep track of all the information that it needs to be able to do anything to plan your travel. And then also it will store everything that you said in the past so that it will also remember things in the future. So you don't have to restart searching and travel. Say if you were to say make a travel plan a year after some time, then it will keep track of everything that you did a year before, and you won't need to re-enter everything. You won't need to tell it everything. You will only need to say things that are new, so that you can have something that's ready available that is catered to your preferences. So kind of the basic structure of the chatbot is that given a user query, it will try to solve it and respond to it. Well, then what happens in between is that first, we need to determine what actually function we need to occur. As of right now, our product can only do one function. Right now, it only plans itinerary. But in the future, the purpose is to expand on this so that you can have a bunch of different features that allow you to have a lot of things that are congregated to one app or one product. So as of right now, it's only a planning itinerary, but in the future, this could expand into things like booking, translations, things like that. And after this, our product will ask you for basic info, the basic things like location, whether you have a budget, things like that, the basic info that they require to kind of get started on the process. And then we gather the necessary data, and then eventually we solve based on what the mode is, what the function is, and we respond back to the user. All of this is powered using OpenAI's API, model GPT 3.5. Everything, it is not one prompt that responds to all of this. Each step has its own prompt so that we make sure that our models are trained so that it performs a specific task and it won't get confused between different tasks. It will be specific to one thing so that it can do it the best way possible. As of right now, the way we gather our data is through Google Places API and Google Geolocation API. The reason we chose to use these two resources to gather data as of now is because it's more simple, and for reasons mentioned later, this was the simplest way as of right now for us to get at least the basic data for us to create this product. Onto a demo, I have something that's pre-recorded because of the free limitations of ChatGPT, OpenAI's model. Their rate limits caused this to be slower because they only allow free prompt. You can only have free users, free inputs per minute, and because our product makes use of multiple calls to the model, this takes a while because of the free limitation. So additionally, I just it asked me how it assists. I tell it that I want to plan a trip. Again, eventually this will be expanded into multiple options, but as of right now, our only function is to plan an itinerary. So it will then start asking me for the basic information, like I said before. Well, provide with the information like budget, location, and how long I want to go. Again, as of right now, the budget, although I do ask it, I'll ask the user for a budget. Our model does not consider budget as of right now because of, again, I will discuss in the future the kind of time constraints we had developing this product and what we were doing. So while it does ask for the budget as of right now, it does not consider it into its calculations, but everything else it does. So after I ask for the basic information, it asks me if I have anything else. I tell it, okay, so I don't have anything right now. Eventually, it will ask for more information depending on what function it's supposed to perform. So after that, it will start giving me some options. It will go search for things. Right now, we only include hotels, restaurants, and attractions. Again, in the future, this will expand. It will also cater to the user more by asking for more preferences and whatnot. But as of right now, it only considers the location and the duration, things like that. So it will give you a list. While the list is it only lists 10 out for the user, there is actually more stored behind the scene so that you can ask it for more options if you want, and it will give you more options. So this is just me asking it about I want to know more about one of the options on the hotels. So I ask it, and it will tell me more about it, things like rating, location, things like that. Right now, our data is more constricted because of the
Right, sorry
things
to
that are given.
interrupt. You have 1 more minute to wrap up.
Thank you. As of right now, it is we have a limited data that we have, so this continues for restaurant attractions, so I'll skip that for now. But eventually, after going through everything that you want, it will give you an itinerary. Right now it's more general, but in the future you'll have more options to add more detail if you want. So kind of our journey, some challenges was, this was for me, it was my first big Python project, so I am not that familiar with Python, so that was a new experience for me. And obviously, like I said before, a big challenge was all the free constraints that OpenAI has. Some of the accomplishments that we had though was in a short time we had big progress. This product, this idea was actually only developed in the second half of the project period, giving us kind of only a little bit less than a month to actually develop this whole thing, because we were originally had a different idea, but it didn't pan out, so this one would work better. And then also some accomplishments was our understanding of the potential limitations of AI, because this is obviously a new field. The public has different opinions on it, but actually working with it allows us to know more about it.
Yeah, thank you, Ryan. I think we are out of time, and I think you are on time as well. Let's open the floor to judges to ask questions. Do we have any question from judges?
Team, this is Annie. Now that you have gone through this experience, looking back at it, would you do anything differently?
Yeah, like I said before, a lot of the big problem was that this idea only came in kind of the last month of the project period. So before we were working actually on something different, something a little bit different. It was related, but not as close to the final product we have now. So kind of what I think happened was that I don't think we spent enough time considering kind of our different options of what to create. So if I were to go back, I would definitely spend a little more time in the kind of brainstorming period to make sure we had a solid idea that we could actually work on for the entire time.
That you had wanted to show us today, had you had time, you know, if you had more time, like you mentioned, you only had about a month of time, but was there a feature or any capability that you wish you guys would have been able to demo today?
Yeah, for sure. Obviously, as you saw in the demo, right now, our kind of visual appearance is only of that of a simple chatbot. Again, majority of that's because we spend majority of our time working on the functionality of the product, not the actual appearance. If I had more time, obviously, we would try to make it so that it's more user-friendly, give it more options, things like that. Another thing is, like I said before, the only option we have right now is the planning itinerary, which kind of does not showcase the kind of big picture of our product. So if I were to go back, I would definitely add a few more things that would kind of, at least one other feature that would kind of show that this is beyond just a planning product and something more that you could take with you to your day-to-day life whenever you're traveling. So maybe say something like a translation or things like that.
Thank you, Ryan. Thank you, team.
Thank you.
Thank you, Ryan. Thank you, all the judges. And thank you, Team Unity.
Thank you so much.
Our next demo is from Team IntelliHealth. And their project is about AI-based health recommendation system. Team lead is Xiangli Zhang. And advisor is Tieyi Guo. Xiangli, go ahead.
Kevin, can you share the screen?
Yes, I did share the screen. Can you see it?
Yes, yes. Who's
Steve.
Steve? You
Okay,
open.
so I'm going to start this. Okay. Good morning, judges and friends. Thank you for being here. In the next 15 minutes, our InterHealth team will present you our work entitled AI-based healthcare and consulting system for diabetes. Next page, please. As we know, diabetes is a chronic health condition which over time can produce serious health problems such as heart disease, vision loss, and kidney disease. Studies conducted by the Center for Disease Control showed that close to 50% adults have diabetes or pre-diabetes in the United States last year alone. Next page, please. Besides effective treatment for diabetes, one of the most important issues we face is to provide accurate and personalized information to audience, including diabetes patients, doctors, high risk, and general population. The fast-growing technology in machine learning, artificial intelligence provide us timely opportunities to counteract this issue. Next, my colleague Kevin will introduce part of the strategy for our project. Kevin, please. Thank you, Steve. In this part, we used 8 technologies in total. For the chatbot, we used the VectorDB and LangChain. And then for the front end and back end, we used React and Flask. For the prediction and the recommendation, we used the large language model from OpenAI and also machine learning model we trained ourselves. For version control, we use, of course, GitHub, and deployment, we used Docker and Heroku. This is an overview of our product. We have 2 components mainly. One is the diabetes prediction and the recommendation. The other one is the user chatbot. For the diabetes prediction and recommendation, we will have 8 parameters for the user to enter, and after that, the user can get the prediction and also personalize the recommendation alongside. The workflow of that is basically we first use the user input and feed it forward to the machine learning model that we trained with the diabetes data set from EHR, which stands for electronic health record, to get to the prediction. And we also do some prompt engineering on the user input and feed it forward to a large language model to get to the recommendation. Next, I will have my colleague Justin to talk to us about his chatbot.
Thank you, Kevin. Sorry, everyone. I just realized my camera is not connected. So I will go without camera. The second component of our system is the chatbot of diabetes QA systems. The QA system was built using OpenAI large language model. User can ask any diabetes-related questions, and the reliable CDC diabetes knowledge base is used to retrieve answers with reference URL. Because the answers may carry uncertainty, also called hallucinations, we strongly advise user to check the provided URL web page for the accuracy. Next page, thank you. The chatbot of diabetes QA system is composed of 3 components: CDC diabetes knowledge base, vector database, and the chatbot systems. The OpenAI embedding models was used to convert the CDC diabetes text content to Pine Core Index vector database. In chatbot QA systems, user can send query questions to the vector database, and the answer was retrieved from the database and sent back to the QA systems. OpenAI large language model text DaVinci 003 was used to generate the answers. Next, my colleague Tim will present the integration of the system.
Thank you, Justin. I'm Tim from IntelliHealth team, and I would like to show you a high-level architecture of the app. As Kevin and Justin mentioned, front end will send requests to back end, and as you see here, the prediction service will communicate with OpenAI GPT 3.5 service and then get feedback. And also the vector query service, we also send query to PyCom vector database and then get the feedback. All this service and frontend will be hosted in will be containerized in the Docker, which provide better isolation, and it's easier for us to build more microservices. And if we need, we can compose with other Docker containers if we want. And finally, this will be deployed to the Heroku, which is a platform as a service. It provides better vertical, it's better and easier vertical scaling and horizontal scaling. And also it has built-in load balancer. And also we can easily monitor the performance. And if there's any spike or something like that, we can get alert. And we do have two environments. One is the develop environment, one is production. So we will test in the develop environment and then release to the production. So this architecture right now is only for demo purpose. In the real production, the front end and the back end will separate it into different computation units or clusters. Next slide, please.
Okay, from here, I will do the lab demo. So we have two parts, and we have two examples provided. Let's see the first example. Since this patient does not have a history of hypertension or heart disease, I assume that he's not having diabetes, which is right. And also based on the information we entered, he provided us some recommendations such as maintain a healthy weight, focus on a balanced diet, what kind of food we should eat and what kind of food we should avoid, portion control, regular activities, and how much we should do per week. And let's see another example if we have time. Yes, since this patient is have a history of heart disease and hypertension, I assume that she will have a higher chance of developing diabetes. And yes, and also the model provided more recommendations, such as follows your doctor's recommendation, also how to lose weight, aim to achieve a healthy BMI, monitor your blood glucose level, and also other stuff, of course. And also seek emotional support. Now let's go into the chatbot. We can ask any questions related to diabetes. Maybe let's try this. So I want to ask this question: how do other factors such as high cholesterol and high blood pressure affect me if I have diabetes? And the answer from CDC website is this. And also in the end, we provided the URL. So if the user are not sure if the answer is actually correct, the user can go into the URL and check for themselves. And we strongly recommend this if the user's question is kind of a boundary question. That means if it's kind of related to diabetes, but is not really, maybe it's like emotional health question, then the answer may not be accurate from this website. So we strongly recommend the user to check the context of the answers to validate for themselves. And yeah, that's it. From there, we'll go into the summary.
Q&A team, sorry, Intel Health team, you have 1 minute. Please use a few sentences to wrap up your presentation. Okay, thank you very much. In the end, we provided a specialized diabetes intelligence system utilizing cutting-edge technologies. We also integrated diabetes prediction with individually tailored recommendation. We also built an efficient QA system with reliable knowledge based on diabetes and secured user input data by containerizing web application. Lastly, our future direction is mainly in 3 directions. First is system functionality. The second is user experience, and the last one is privacy and security. For system functionality, we're looking to collaborate with medical experts and also to develop some other models to get more accuracy and more models to monitor the hallucination from our chatbot. That's it. Thank you. Thank you, Intel Health team. Let's open the floor to judge to ask questions. Judges, do you have any question?
I got a question. Can you explain how you trained your model based on what you have? So I missed the part. Are you using GPT 3.5 or using some other large language models?
Are you referring to the prediction model or the chatbot?
The prediction model.
Oh, prediction model.
Yeah, what's your LLM model there?
The prediction model is not a LLM model. It's basically a.
What about the LLM portion? Are you using GPT technology or using others?
Okay, so for the prediction and recommendation part, we use the OpenAI. All we did, we just did some prompt engineering on the user input. And for the machine learning model, we get the data set ourselves from the electronic health record with 9 parameters, and we clean it ourselves and also train the model. So we get the prediction result from the machine learning model and the recommendation from the OpenAI ChatGPT.
Got it. So do you have any plans to improve your LLM model? The reason I'm asking is because with particular disease, you will need to get additional information because you're specializing in certain directions. So you would have to possibly build something to improve your LLM's capabilities. Because we were doing something similar, but we're doing it in a lot more areas. So I'm interested in how you improve your model's capability in terms of providing diagnosis, in terms of making recommendations and improving your accuracy.
Yes, of course, there's a lot of improvement on the recommendation part. And we're thinking to add history into it. So as the patient condition change over time, we can provide better recommendation based on history of the patient. And also we're looking to combine that with the chatbot. So when the user asks the chatbot, we can give a specific answer related to his personal condition. Maybe he has diabetes or not. So that we can provide better answers and also recommendations in the future.
Okay, thank you.
Thank you.
We can take one more question from Judge.
What's your prediction accuracy? Did you do any measurements? Yeah, what's your sample size in terms of training your model and testing?
I believe the prediction accuracy is 96.7%, and the sample size is around 10,000. Yeah.
For how about you? Okay, so okay. What's your source? What's your source?
Our source is from Kaggle, and that data is coming from electronic health record, which is like a storage for multiple healthcare providers. So like hospitals and other stuff. Yeah.
Okay. Thank you.
Thank you, Intel Health team. Thank you, all the judges.
Thank you, guys.
Thank you.
Thank you.
Our next demo team is Team AI Mavericks. Their project is AI-based health recommendation system. Team lead is Jianlei Zhang. Advisor is Tieyi Guo. Floor is yours, Jianlei. You are actually sharing your screen instead of the guest viewer screen, Jianlei.
Hi. So I need to unmute myself. Hi everyone. So thank you. Thank you everyone. So let me share my screen. Are you able to see my screen? So
not yet.
Yeah. So here our teammate AR Henrik. Here is.
Sorry to interrupt. We haven't seen your screen yet.
Oh. Are you able to see it?
We are seeing the small ones of your screen. If you can switch, do a swap display.
So now you are able to see?
Yeah, this is perfect. Floor is
Okay.
yours.
Yeah, thank you. So our team's our advisor is Tie Guo, and our project is AR-powered medical doctor recommendation system. So this our objective is to help the visitor to find the medical doctor based on their bio data and medical record, their symptom and their preference, such as the addresses and the time. So we have the feature like the model can consider the visitor's bio data, include the gender, age, smoke or not, and the medical records. And this our application also can provide the multiple turn conversation to interactively collect the visitor's symptom. And also when the model collects enough information, the model will decide the medical category, and also it provides an explanation of such a decision. And also the last but not least, the application can help to make to schedule a doctor, find a doctor, and confirm by the email, given the visitors' addresses and the time. Here are the overall system diagram. It's initially have the form. The user need to fill out the form and submit the form, and the user identification will go to the database. It will carry out the medical records and also the bio information. Both they go to the chat OpenAI chat GPT 3.5 here we use, and also the email address will use for later appointment. And given the user's information, the bot will interactively ask the user to provide more information about the one's symptom. If there are no enough information to make decision, so the bot will ask proactively. And until the user provides enough information, a medical category will be recommended. There are also such a situation, there are no clue information. There is a default category called general practitioners as a category. And after the category gets decided, we'll move to the next step. That's the next step is the flow and the rule-based logic, which provides the appointment workflow. So given the medical category and the visitors information, there are several API which developed by Andrew Wu. You want to take a sentence? So this application will query the Google Map and get a list of clinic and medical doctor in the category given the user address, and also given the clinic there is a web scraping to gather the more information about this specific doctor. This is work done by Victor Lee. You want to take a comment? Okay, I think that probably is hard to switch over. Okay, Now, after the user select look over the information about the doctor, and the user will decide which doctor to select. Then we'll be move to the next step. We'll go to calendar. This calendar has the connection to the doctor's calendar to get the available time slot, and the user choose the availability time given the doctor's schedule. And the next step will be automatically send a confirmation email to the user, which fill out at the beginning. Here is the flowchart for the chatbot. It starts with the form with the bio information and identification information, and then greeting by the bot. Then will be the turn-by-turn conversation. And if the medical category gets found, then we'll go to the next step. If not, the conversation will continue. And if for the appointment stage, if the user say no, so it will be end of this conversation. If yes, will be moved to the next step. So the user will select the provided medical doctor and also select the time slot and also do the confirmation. This will end the conversation. So what we use to customize the ChatGPT, we use the in-context learning. So the ChatGPT operation is provide the common sense and the chatting capability, and also we have the in-context learning, which include the logic about how to do the medical doctor category categorization logic, and also the system rule. We also consider the patient's biodata, the age, gender, or medical records is get considered. And then we'll move to the application demo, which is by Louis. I will start.
Okay. Can you see my screen?
It's loading.
Can you see my screen?
Yes.
Yes.
Okay. Let me first introduce what we do. Simply put, we implement AI health assistant based on large language model. It's something like a patient diagnostic and triage system. And it's not the entire case, as we can talk to the chatbot like a real person. After the chatting, it will recommend the suitable doctor category. So how to use it? We click the button to first fill out a form with a bunch of your health information, including health, age, health, weight, smoke or not, medical records, and allergy. We filled already, so we click to start chatting. So for the first chatting part, we will demo 2 patient cases. Here the first, we begin with a brief greeting and a sort of help. It return with something like what symptoms you have, how can I assist you. So we propose concerns of health issues, and I think this issue may trouble you sometimes, right? And it returns with inquiry for more details, including do you have experienced this difficulty for a long time, or it is a recent issue? Have you noticed any specific triggers or patterns that might be contributing to your health difficulties? So with more details, so add more details. We can say we have sleep difficulty for 1 month, and sorry for that. And we can also say
Can you try to wrap up your presentation in a couple of few sentences? We have 1 minute left.
Okay. So we can say the heart feels not so good. It's not so good. It beats so fast. It beats so fast. Sorry for that. So we can say what it replies in this section. It gives us the category we recommend you to see, and it gives some reasons. What it says is difficulties falling asleep and an increased heartbeat can be connected. Based on your symptoms, it's possible that you may experience a combination of sleep-related issues and cardiovascular concerns. And it totally makes sense, right?
Luis, sorry to interrupt. We are out of time, but you won't lose the opportunity to share more details with the judges during the Q&A session.
Okay.
So let's open the floor to judges to ask more questions.
Hello?
Yes.
Hello.
Hi.
To my understanding, so your AI health support system, mainly focus on, for example, the patient, the input text, like issues, So then your system can smartly give the recommendations to see the appropriate doctors, right?
Yeah. Category.
Yeah.
Okay, so can you tell us so what's the main the technique, the challenges when you conduct this project?
I think we have the in-context learning. What included in the in-context, we provide some domain knowledge logic to help the ChatGPT to make the categorization, and also we provide the patient's bio data to help to make a decision. So that's how this work. We did do some tuning work and try to help to make the better categorization.
Okay, what kind of data source you use?
So the logic we get from we collect from some web page, and then we use that to by the ChatGPT itself to generate some logic, the rule-based logic, and then we input back.
All the just the crowd from the web page, the data source.
Yeah.
It's from the web page. Specifically, it's from the catalog of doctors in the that's a website of the doctor catalog, and it's sort of like a database, and we extract all information from there.
Okay. Thank you.
Do we have more questions from judge? Okay, I take that as no. Thank you so much for AI Mavericks, and thank you for all the judges.
Okay, thank you.
Thank you. Our last team for today is Team Texas A&M AGIS. They are going to present the project College GPT, Voice or Chat Bot. Team lead is Jeffrey Xu. Advisor is Julian Liang. Jeffrey, floor is yours.
Yeah, thank you. I'll share my screen. Can everyone see my screen right now?
Yes.
Perfect. Oh, not like that. Sorry. Let's show. Yeah. So hello, everyone. My name is Jeffrey. Our team chose Project One, College GPT, and our team consists of me, Jeffrey, David, Albert, and Alan, but Alan can't make it today. So to introduce our problem, essentially an issue that many college students encounter every single semester is trying to organize all their courses and trying to basically put down where all their important assignments are and what days they occur. And oftentimes before every semester begins, each student will sit down for 4 or 5 hours and go through every single syllabus that they have and individually pin down the like assignment dates, which assignment it is, just so they can stay like more organized during the semester. And obviously, because this takes hours, it is not very practical. So what we wanted to do is kind of provide an application or an interface that can help students quickly organize all these exams and assignments and have all the dates already organized for them so they don't have to worry about it. So what we were thinking, at least, was that we would have an application that could extract all that information from a class syllabus. So every single professor will essentially give out a syllabus at the beginning of the semester, and it'll give all the important dates and like how many homeworks they have, things like that. So what we wanted to do was to provide an easy method for students to essentially get those dates and important assignments from the syllabus and basically automatically upload them into their calendar somehow. So instead of, worrying about organizing for their class, they can just focus on learning the material, which is obviously the most important task for a student. So next up, I'll let David cover our solution architecture and live demo.
So on the front end, it's written in Flutter. It implements logging in via Google, as well as communicating with the Google Calendar API to send requests that add the events to the calendar. In addition, it communicates with the backend server, which is in Django. So most of the intensive processing occurs there, including running an LLM locally. It also communicates with the AWS OpenSearch database that we use for embeddings for the user's uploaded documents, which you can upload in the front end. And the types of documents can range from PDF to CSV to just simple text files. So, yeah. So now for some more details, yeah. As I mentioned, the front end is in Flutter, and the back end is in Django, and it does the actual document processing. So in more detail in the back end, we used several technologies. So for the LLM itself, we used a Llama 2 model, which was developed by Meta. So we use LangChain to easily extract the text from documents, as well as splitting it into smaller chunks. And then it also makes a request to OpenSearch to add the embeddings to the database after they're embedded with another embedding model. And then there's also AutoGPTQ, which is a library that enables the user to run quantized LLM models. So in this case, it's running a 4-bit quantized model so that it could actually fit in our memory locally, because running LLMs takes some expensive hardware. And yeah, next, JSONformer is a library that we used in order to restrict the output of the LLM to convert to a JSON format. And this enabled us to reliably get the output from the LLM and use it as input for coding other places. Then finally, LMQL is another library that helps to restrict the output of the LLM. It lets us, in the case of the chat interface, when the user chats with the LLM, the LLM is capable of referencing the documents that the user has uploaded, and LMQL first restricts its output to a yes or no for whether it wants to search for more information or not. And then it actually performs search if needed, so it's not always doing it. Yeah, and then yeah, we can go on to the demo to just show what our website looks like. Yeah. So here, you have the home page. You can log in with your Google account. In this case, I logged in with my own. And after logging in, there will be a homepage with the chat interface. You can add courses first. Let's just call it test. And yeah, you can also view the uploaded files. I had some files uploaded, but I deleted them. And that also deletes them from the database. So you can upload files. Here I selected that syllabus as a syllabus. Yeah, and after a few seconds it finishes uploading. Then you can see the files were uploaded. And then here's the functionality for importing events. It takes the it searches for any relevant dates through the on vector search, and it finds well, sometimes it finds that there aren't any relevant events in what the search results are. It takes the LLM and processes the results. Here you can also change the dates or the title of the event, but you can, after that, yeah, clicking the add button adds it to the calendar. There's also the functionality you can save or add or delete more of the courses in the corner. Yeah, and now so here you can see we started chatting with the LLM, just saying a hello. It's going to take a while to run because, again, hardware limitations. LLMs running locally, they take a lot of processing power with a good GPU. But yeah, here it finally returned the results. And in this case, it decided to search for information from its uploaded documents. And yeah, so now I'm going to ask it a question related to the syllabus that was uploaded. And so it's going to take a while to process the request again, and it'll be searching for the relevant information through OpenSearch. And it's included, it's used to augment
there might be a problem with the screen resolutions. I cannot see it clearly. Do other people see the same problems? It could be just on my side.
Screen seems quite dark.
Yeah, it impacts your demo.
I think the video is just a little dark, but it's
okay.
Oh,
Yeah,
yeah, sorry.
Okay.
Yeah. Okay. Yeah. So if you can see here, it returned a response generated by the LLM after it retrieved some information from the syllabus regarding the dates of some exams that it found. And yeah, that's about it. You can sign out from the corner, and yeah, that's it for this demo.
Yeah. Thank you, David.
So Jeffrey, your team have 1 minute left. Could you wrap up with your sentence?
Yeah, and then Albert.
Yep. So basically, some challenges we faced during this project was we had to change our original tech stack. So we had to change our database from S3 to OpenSearch in order to properly store embeddings. And in the future, we hope to enhance the project by adding more features we originally planned, and of course, using better hardware for the backend to make it more efficient. And
yeah, are there any other questions?
So yeah, let's open the question floor to all the judges.
Thank you for presentation. My question is, most of college students, they're taking multiple courses. Will this tool be able to resolve any, for instance, schedule conflict, or optimize the schedule or location, class location?
So currently, we did not implement any type of scheduler into our application. Because this tool is not really built as a scheduler, it's more as a tool to streamline the organization process that students like experience usually at the beginning of every semester, and to help them with studying and querying notes. We didn't really account for scheduling, but obviously it is like a nice feature to have, I think. But ultimately, like, scheduling is a pretty tough problem. And usually when we're like kind of coming up with a solution for our project, we decided that all of that work oftentimes requires like a lot of factors. So students they might be living in a certain area, and when they schedule, they need to be thinking about traveling from class to class. They might also have other things outside of class, such as they might have internships or jobs and things like that. So because our application can't really capture all of that information, we decided to leave that out of the scope of the project currently. But in the future, like, that could be a improvement on the application.
Okay. In some syllabus, the faculty actually do not provide that information, like the date information on the assignment or quizzes. So how do you treat those scenarios?
Yeah, so as David showed in the demo, is like, if it can't extract any dates or anything, then it'll let you know that it wasn't able to extract any dates. But if a professor doesn't like publish any of their dates like on any documentation, then obviously we can't extract that information out because it's like not stored anywhere. And oftentimes in those cases, professors will just email you or manually like tell you in class like what days there are. I know some professors, they kind of are pretty free with their schedule, and in that case there's not much we can do because it's kind of up to the professor's discretion. But that's kind of how we handle those cases.
Okay, thank you.
Yeah.
Do we
Any other
still have
Got a question?
Yes.
Yes. All right, go ahead.
Okay. So first question is, so for your current system, do you only focus on the student, the planning for the student, the organization planning for those classes, the student register, or it can for planning for any classes for future planning, not register class?
Yeah, so it's currently configured to deal with registered classes because that's the only way you can get a syllabus. Because we kind of centered our entire architecture around extracting information out of like a course syllabus. Similar with the previous question about scheduling, like for unregistered classes, this is kind of up to the students' discretion on how they handle those, right? Like how they do like research and things like that. But one of like the functionalities that we wanted to have was to have like be able to query notes and from the internet using like ChatGPT and things like that. So something that we could implement in the future is providing some sort of resource where students can research future classes that they may take and see like which professors are good and like, how each class is structured and things like that.
I think it depends on the university. For example, in our UTD, even the student not register for that class, but the syllabus, yeah, so and the like some kind of the like the materials, yeah, so may also for some professor may also open, yeah, so it's the open source for all the students. Okay.
Yeah, so like if they have a syllabus, that's the what our app is centralized around. Like if they can access the syllabus, then they can extract all the relevant info. So it's kind of like whatever the student, it's kind of up to the student to organize it in that manner.
Yeah. So another question is, yes, for your current system, looks like you are only, yeah, so like the the data input is only came from the syllabus. Is that right?
Correct.
Yeah. Okay. If that is the case, yeah. So for example, like just the scenario for my class, yeah. So I do like post the syllabus. However, the syllabus, I do have some kind of the dates. However, that is just the tentative. That is not the like the actual, yeah, because based on some kind of the like the actual class, the like the progress. For example, if in the winter we have some kind of the inclement day, the weathers, yeah. So for the project, for the homework, we may have the updated date as the syllabus. So for my, yeah, so style, I usually, for the syllabus, once it posted, I will not keep the update. So the student need to go to the registered the e-learning. We use the e-learning, the student actual system. Yeah, so the all the like the updated, the accurate, the homework due, project due, like the important announcements will be updated in that system. So I think maybe later you think about to also link the, especially when you do the organizations for the student, the registered class. So you may think about something to link with the like the student, the like the system for the actual course information.
Thank you, Judge Wu and Jeffrey. That's very good comment. Given the time, could you address Judge Wu's comment in the chat? And if other judges have more questions, feel free to post your questions in the chat. Given the time, I would like to provide a quick conclusion remark. Congrats to all the advisors and the contestants. You have successfully demoed your projects. Congrats to all the volunteers. The demo meeting starts on time and we will end on time. Today's meeting runs very smoothly. Thank you all the judges for your precious time. Thank you all the sponsors for your generous support. And I will announce today's meeting will end now. If you have more interest or questions, we still have three more minutes to keep the line open. Feel free to post your questions and answers in the chat. Thank you very much.
We have a PM session to continue with more presentation and demo. So feel free to join in the PM session.
Correct. Thanks, Maria, for reminding. We will have our session demo 2 tonight from 7:30 to 10 Central Time. If you are interested to hear more about other teams' demo, feel free to join.